Hello everyone and welcome back. My name is Mr. Cobalt and in this video I'm going to be going over how to use molar mass in your calculations. In other words, how to use molar mass as a conversion factor. So let's get into this. So the first part of this problem is they want us to write a conversion factor to convert between grams of P4O10 and moles of P4O10 molecules. So, what conversion factor would I use to go between grams and moles? Molar mass, right? So molar mass is the conversion factor of how many moles, excuse me. So how many grams of a substance is equal to 1 mole of that substance? If we could figure that out, then we would have a relationship between moles of that substance and grams that we could then use as a conversion factor. So all we need to do is calculate the molar mass of this substance. And the way you do that is you use your periodic table and you look up the atomic masses of the elements that make up your substance. So here we have P4, that means we have phosphorus. We have 4 atoms of phosphorus, and we have oxygen, 10 atoms of oxygen. So all we need to do is look up the atomic masses of phosphorus and oxygen and add all of those together. So basically, it would look like this. So I have uh, 4 phosphorus atoms. So I'm going to take that and I'm going to multiply it by whatever the molar mass on the periodic table is, or whatever the atomic mass on the periodic table is. And I looked that up and it says 30, 97, 38. So 30, 97, 38. Now, different periodic tables have different numbers of decimal places that they put. So yours might cut off at 2 decimal places or 3. It doesn't matter. Just use whatever your periodic table gives you. It should give you pretty much the same answer as what I'm going to get. So this is the atomic mass of phosphorus. I have 4 of them, so I'm going to multiply that by 4. And then I'm going to add to that the amount that I have for oxygen. So if I look up the atomic mass of oxygen, I get 15.9994. I have 10 of those, so I'm going to multiply that by 10. So what was that again? 994. 15.994. Now again, some periodic tables are going to 16.00. Some are going to say 15.99. It really depends on what table you have. So whatever the number your table gives you, just put that number down. Again, it's not going to be that much different from what I'm going to get. And so when I multiply and add those together, I get 283. 283 point, was it 889? Yes, 889. 889. So that's the total molecular mass. And so now I have the molar mass of my P4O10. So what this gives me is the number of grams that's equal to 1 mole. So I can write that as such. So 283.889 grams of P4O10 is equal to 1 mole of P4O10. So I can write this as a conversion factor. And a conversion factor is basically you're writing these two things together as a ratio or a fraction, if you will. So you're going to have a ratio, and you have 2 possible ratios. One can go over the other, or you flip it. So there's 2 possible conversion factors here. So either you can put the 283.889 grams of P4O10 on the top, and then put 1 mole of the P4O10 on the bottom like that, or you can flip it. So I can put the 1 mole. So I can put 1 mole of P4O10 on top, and then put the grams, the 283.889 grams of P4O10. So there's 2 possible conversion factors for any molar mass, any molar mass you calculate. So now that I have the conversion factor, now that I have the molar mass, the grams per mole of this substance, now I can answer the second question. So here they're asking, what is the mass in kilograms of this many moles of my tetraphosphorus dicoxide? Well, what is tetraphosphorus dicoxide? It's this substance here, tetraphosphorus dicoxide. Okay, P4O10. So the way I'm going to solve this problem is I'm going to use molar mass as a conversion factor because they're giving me a number of moles and they want me to go to mass in kilograms. Well, to go from moles to mass, I need to use the molar mass. So I'm going to start with the moles they give me. Oops. Sorry about that. So I'm going to start with the moles they give me. So it's 8.80 times 10 to the 4 moles of P4O10. I'm going to put it over 1. And now I'm going to start multiplying by my conversion factors. So since they're giving me moles and I got to get to mass, the first conversion I have to do is using molar mass. I got to get to mass somehow. And since molar mass gives me a relationship between mass and grams and moles, I can use that. So since I have moles on the top, I'm going to put moles on the bottom. So 1 mole of P410 goes on the bottom. O10. So P4O10 on the bottom. So moles, and then the mass, the grams, goes on top. So this one here. So I'm going to have 283.889 grams of P4O10. So the moles cancel out, and I'm left with grams. But they want kilograms. So I'm not done. I gotta go to kilograms. So here I can use my metric relationship between kilograms and grams. I know that 1 kilogram is equal to 1,000 grams, or 10 to the third grams. So I can now use that as a conversion factor between grams and kilograms. So let me write that down. So my next conversion, since I have grams on the top, I'm going to put grams on the bottom. How many grams? 1,000 grams. So I'm going to put 1,000 grams of P4O10 on the bottom and 1 kilogram on top. So 1 kilogram P4O10 on the top. So grams of P4O10 cancel out. Now I have kilograms of P4O10 on the top. That's what we want. We're done. So now all you need to do is multiply across the top, divide by everything on the bottom, and you'll get your answer. And the answer I calculated is 2.50. 2.50 times 10 to the 4th kilograms of P4O10. Now, for those of you who are interested in the sig figs, notice I put this in 3 sig figs. The reason is because if you look at number sig figs, remember the rule for multiplying and dividing is that your answer should have the same number of sig figs as the measure or the uncertain or how should I say, the inexact measure um, uh, that you multiply and divide it. So here, the 1 to 1,000, that's exact because this is metric to metric mass. This is molar mass, and you'll notice here the molar mass is 6 significant figures. And here we have 3 significant figures. 3 is the smallest number of sig figs. So that means that our answer should have 3 sig figs. So we have 2.50. And that's it for this video. I hope that you enjoyed this. I hope this helped you understand how you can use molar mass as a conversion factor to help you calculate and convert between moles and grams. If this helped you in any way, then please, by all means, like the video, share the video, hit that like button. Also, make sure you subscribe to my channel, hit that notification bell, and when you do, make sure you click all. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. If there's a topic you want me to go over or a problem you want me to solve, then I would be happy to do that for you. Thanks for joining me, and have a great day.